Hello and welcome to this module on Introduction to Unsupervised Learning. Right. So, in supervised learning, we looked at how you will handle training data that had labels on it. So, in this particular case, this is a classification data set where red denotes one class and blue denotes the other class, right. And in unsupervised learning, right. So, you basically have a lot of data that is given to you, but they do not have any labels attached to them, right. So, we will look at first at the problem of clustering, where your goal is to find groups of coherent or cohesive data points in this input space, right. So, here is an example of possible clusters. So, those set of data points could form a cluster, right, and again now those set of data points could form a cluster, and again those and those. So, there are like four clusters that we have identified in this setup. So, one thing to note here is that even in something like clustering, so I need to have some form of a bias, right. So, in this case the bias that I am having is in the shape of the cluster. So, I am assuming that the clusters are all ellipsoids, right, or and therefore you know I have been drawing a specific shape curves for representing the clusters, and also note that not all data points need to fall into clusters, and there are a couple of points there that do not fall into any of the clusters. This is primarily a artifact of me assuming that they are ellipsoids, but still there are the points in the center is actually far away from all the other points in the data set to be considered as what are known as outliers. So, when you do clustering, so there are two things. So, one is you are interested in finding cohesive groups of points, and second is you are also interested in finding data points that do not conform to the patterns in the inputs, and these are known as outliers, right. And so, there are many different ways of which you can accomplish clustering, and we will look at a few in the course, and the applications are numerous, right. So, here are a few representative ones. So, one thing is to look at customer data, right, and try to discover classes of customers. You know, there are, so earlier we looked at, in the supervised learning case, we looked at whether a customer will buy a computer or will not buy a computer. As opposed to that, we could just take all the customer data that you have and try to just group them into different kinds of customers who come to your shop, and then you could do some kind of targeted promotions at different classes of customers, right. And this need not necessarily come with labels. You know, I am not going to tell you that okay, this customer is class 1, that customer is class 2. You are just going to find out which of the customers are more similar with each other, right. And the second application which I have illustrated here is that I could do clustering on image pixels, so that you could discover different regions in the image, and then you could do some segmentation based on that different regions. So, for example, here you have a picture of a beach scene, and then you are able to figure out the clouds and the sand and the sea and the tree from the image. So, that allows you to make more sense out of the image, right. Or you could do clustering on word usages, right, and you could discover synonyms, and you could also do clustering on documents, right, and depending on which kind of documents are similar to each other, right. If I give you a collection of say 100,000 documents, I might be able to figure out what are the different topics that are discussed in this collection of documents. There are many ways in which you can use clustering. Rule mining, and so I should give you a aside about the usage of the word mining here. So, many of you might have heard of the term data mining, and more often than not the purported data mining tasks are essentially machine learning problems, right. So, it could be classification, regression, and so on and so forth, and the first problem that was essentially introduced as a mining problem and not as a learning problem was the one of mining frequent patterns and associations, and that is one of the reasons I call this as association rule mining as opposed to association rule learning, just to keep the historic connection intact, right. So, in association rule mining, we are interested in finding frequent patterns that occur in the input data, and then we are looking at conditional dependencies among these patterns, right. And so, for example, if A and B occur together often, right, then I could say something like if A happens then B will happen. Let us suppose that you have customers that are coming to your shop, and whenever customer A visits your shop, customer B also tags along with him, right. So, the next time you find customer A somewhere in the shop, so you can know that customer B is already there in the shop along with A, or with very high confidence you could say that B is also in the shop at somewhere else, maybe not with A, but somewhere else in the shop, right. So, these are the kinds of rules that we are looking at, association rules, which are conditional dependencies. If A has come, then B is also there, right. And so, the association rule mining process usually goes in 2 stages. So, the first thing is we find all frequent patterns. So, A happens often. So, A is a customer that comes to my store often, right, and then I find that A and B are pairs of customers that come to my store often. So, if once I have that, right, A comes to my store often and A and B comes to my store often, then I can derive associations from these frequent patterns, right. And so, you could do this in a variety of different settings. You could find sequences in time series data, right, and where you could look at triggers for certain events, or you could look at fault analysis, right, by looking at a sequence of events that happened, and you can figure out which event occurs more often with the fault, right. Or you could look at transactions data, which is the most popular example given here is what is called market basket data. So, you go to a shop and you buy a bunch of things together and you put them in your basket. So, what is there in your basket, right. So, this forms the transaction. So, you buy say eggs, milk and bread, and so all of this go together in your basket, right. And then you can find out what are the frequently occurring patterns in this purchase data, and then you can make rules out of those. Or you could look at finding patterns in graphs. That is typically used in social network analysis. So, which kind of interactions among entities happen often, right. So, that is a that is another question that is worth looking at, right. So, the most popular thing here is mining transactions. So, the most popular application here is mining transactions, and as I mentioned earlier, transaction is a collection of items that are bought together, right. And so, here is a little bit of terminology, and a set or a subset of items is often called an item set in the association rule mining community. And so, the first step that you have to do is find frequent item sets, right, and you can conclude that item set A, if it is frequent, implies item set B if both A and A union B are frequent item sets, right. So, A and B are subsets. So, A union B is another subset. So, if both A and A union B are frequent item sets, then you can say that item set A implies item set B, right. And like I mentioned earlier, so there are many applications here. So, you could think of predicting co-occurrence of events and market basket analysis and time series analysis. Like I mentioned earlier, you could think of trigger events or faults, causes of faults and so on and so forth, right. So, this brings us to the end of this module introducing unsupervised learning.